Open a new conversation with Claude and it has no idea who you are. The hours you spent yesterday explaining your project, gone. It feels like amnesia. It isn't. It's the single most deliberate design choice in the entire system, and once you see it, you can build around it. Last time, we went inside MCP, the protocol that lets Claude act in the real world. But acting in the world is useless if you can't remember what you did. So today, we go inside memory. The 3 different places Claude stores what it knows. Why one of them resets every single session. What survives and what vanishes the moment you close the tab. And how the best builders turn a model that forgets into a system that never does. To understand why Claude forgets, you have to stop thinking about memory as one thing. Claude has 3, and they could not be more different. The first is its weights, the model itself. During training, Claude read more text than a person could finish in 10,000 lifetimes, and all of that reading was compressed into billions of numbers. That's its long-term memory, how language works, facts about the world, patterns of reasoning. It's vast, it's permanent, and it's completely frozen. Claude can't learn a new fact into its weights by talking to you, any more than you can rewrite your own childhood by thinking hard about it. The second is the context window, the working memory of a single conversation. This is the scratch pad. Everything you've said, everything Claude has said, every document you've pasted, all held live, all at once. And the third is external memory. Files, notes, databases that live outside the model entirely, that Claude can read at the start of a session and write to at the end. Frozen weights, a temporary scratch pad, an external notebook. When people say Claude forgot, they almost always mean the middle one got wiped. So let's go inside it. The context window is a container with a hard edge. It holds a fixed amount of text, and only what's inside it exists. Everything else is invisible. When you open a new chat, that container is empty. As you talk, it fills. And here's the part that surprises people. When the session ends, the container is thrown away, not archived, not quietly saved to a database somewhere, discarded. This is fundamentally different from how humans forget. Human forgetting is decay. The memory was stored, and it faded, and a fragment might still surface years later. Claude's forgetting is erasure. The information was never written down in the first place. The conversation lived in the scratch pad, and the scratch pad was wiped clean. That sounds like a pure liability. It hides an upside. Because nothing carries over, every conversation starts from the same stable baseline. Claude doesn't hold grudges. It doesn't slowly drift into bad habits from one strange interaction. It doesn't get more biased the longer you use it. The model that talked to you yesterday is, byte for byte, the same one talking to you now. The cost isn't corruption. The cost is that you have to re-establish context every single time, and that cost compounds the moment you try to build something real. Inside a single conversation, though, Claude's memory is extraordinary. Everything in the window is live at once. The instruction you gave in your very first message, the 40-page document you pasted at minute 3, the code you wrote together an hour ago. Claude can cross-reference all of it, catch a contradiction between something you said early and something you asked late, build on reasoning from 20 exchanges back. A long, well-structured conversation isn't a chat log. It's an active workspace, and these windows are enormous now. Current Claude models hold hundreds of thousands of tokens. A token is about 3/4 of a word, so that's entire code bases, full research papers, hours of transcripts, all in context at the same time. But here's the trap almost everyone hits. The limit you run into first usually isn't the size of the window. It's attention. As a conversation grows, not every part pulls equal weight. The model leans hardest on the most recent text and the most prominent text. Bury a critical instruction in the middle of 100 pages, and it can get quietly outweighed. So the lesson is counterintuitive. A bigger window doesn't mean you can be sloppier. It means structure matters more. Where you put information inside the window changes how much it counts. So how do the best builders make a forgetful model feel like it remembers everything? They stop fighting the scratchpad and start managing the notebook. There are 4 moves. The first is persistent context files. Before a session even starts, you write the important things, who the user is, the rules, the current state of the project, into a document, and load it at the top of every conversation. Claude is oriented in seconds with no re-explaining. The second is memory tools. Using MCP, the protocol from last episode, Claude can write to an external store at the end of a session and read it back at the start of the next. It summarizes what happened, saves it, and reloads it tomorrow. Crude, but it works. The third is retrieval. You store thousands of past notes as embeddings, mathematical fingerprints of meaning. And when a new question comes in, you fetch only the handful that are actually relevant and slot them into the window. That's how a product can seem to recall one detail from 6 months ago. And the fourth is compaction. When a conversation gets too long, Claude summarizes its own history, replaces the bulky transcript with that summary, and keeps going. The work continues. The window stays sane. None of these change the model. They change what the model can see. Step back, and you realize this isn't a technical footnote. It's the foundation every serious AI product is built on. If you're building a support agent, the real question isn't which model. It's what context loads for each ticket. If you're building a coding assistant, it's which files enter the window and which stay out. If you're building an agent that runs for hours, it's how it carries state forward without drowning in its own history. These aren't details you bolt on at the end. They are the architecture. There's even a name for it now, context engineering, and the teams shipping the best AI spend as much time on it as they do on the prompts themselves, because a model with the right context at the right moment beats a smarter model with the wrong context every time. And it reaches all the way up to trust. An agent that forgets everything between sessions has to re-earn your confidence each time you return. An agent with well-structured, persistent memory accumulates context and gets more useful and more trustworthy the longer you work with it. Memory isn't a storage problem. It's the difference between a tool you use once and a partner that grows with you. The best builders understand that the model is only half the system. The other half is what you let it remember. That's memory and context, the invisible architecture behind every conversation you have with Claude, and every product built on top of it. If this changed how you think, subscribe. Next, we go all the way back to the beginning, inside Claude's training, the data, the choices, and what they mean for the AI you're actually using.